Hi everyone, I am Bindeshwar from Post Network Academy, and in this video you will understand what is variance and standard deviation. Variance or standard deviation have similar concept and a very important concept in statistics, data science, machine learning, data analytics and artificial intelligence. And also in economics and other areas. Now let us see what is variance. First of all, I am going to write definition of variance and thereafter standard deviation. So variance of a variable x is the mean of the squares of all deviations of x from the mean of the observations. So this is the definition. And what does variance measures? So variance measures scatteredness of a data or spreadness of a data. If it has high variance, that means the observations are very diverse. If in extreme case, if all observations are the same, so variance would be 0. So it measures spreadness or scatteredness in data set. Now let us write the formula. So sigma square or variance of x is equal to 1 upon n, where n is the number of observations, summation over I is equal to 1 to n xi, that this is observations minus mean of observations, and whole square. So variance of a variable x is the mean of the squares of all deviation of x from the mean of the observations. So that definition, if you see carefully, so this formula will come in the result. Now let us see what is standard deviation. So standard deviation is the positive square root of the variance of a variable x. So this means that standard deviation under root variance of x, or 1 upon n summation over I is equal to 1 to n xi minus x bar का whole square. So you will take positive one, not negative one. And also that can be denoted as sigma, because sigma square is variance, so sigma is standard deviation. Now let us see an example. So I am taking an example which has 5 individual observations. So this is individual data. So values are 8, 12, 13, 15 and 22. So first of all you will calculate mean. So I will denote it by x bar. So sum of all observations upon 5. Number of observations, which is 5. So 8 plus 12 plus 13 plus 15 plus 22. And divide it by 5. So if you calculate, that will come 14. Now let us write the data difference from observations to mean and square of observations minus mean in a tabular form. So if I write xi minus x bar and xi minus x bar whole square, so that would be 8 xi minus x bar. So 8 minus 14, that would be equal to minus 6, and the square of minus 6, that would be 36. Thereafter second one 12, so 12 minus 14, that would be minus 2, and the square of minus 2 would be 4. Thereafter third observation 13, 13 minus 14, that would be minus 1, and the square of minus 1 would be 1. Thereafter 15, 15 minus 14, that would be equal to 1, and the square of 1 would be 1. Thereafter 22, 22 minus 14 would be 8, and the square of 8 would be 64. Now if you add them, 64, 36 plus 4 would be 40, 40 plus 1 would be 41, thereafter 41 plus 1, that would be 42, 42 plus 64, that would be equal to 106. So I am writing here 106. Now what would be the variance? So here I am writing variance would be 106 upon 5, that would be equal to 21.2, because formula of variance is 1 upon n summation over I is equal to 1 to n xi minus x bar whole square. So n is 5 and sum of xi minus x bar means would be 106. Now variance is 21.2. So standard deviation would be under root 21.2, that would be equal to 4.60. So that was how to calculate standard deviation. Now I'm going to take another example. So I'm taking 10 individual observations. Example 2. So these are 65, 68, 58, 44, 48, 45, 60, 62, 60 and 50. If you calculate mean of these observations, so these are 10 observations. I am also writing so that you will remember 10 observations. So n is equal to 10. So let us calculate mean. 65 plus 68 plus 58 plus 44 plus 48 plus 45 plus 60 plus 62 plus 60 plus 50 upon 10, and that would be equal to 56. So calculate it if you are interested. Now let us write xi observations minus mean and observations minus mean square in a table. So xi 65, here xi minus x bar and the square. So xi minus x bar whole square, 65 and mean is 56, so 65 minus 56, that would be 9. If you square it, so 81. Next observation, 68. I'm taking from here 68. So if you subtract 56 from 68, that would be equal to 12. And the square of 12 would be 144. Third observation, that is 58. And if you subtract 56 from 58, that would be 56. That would be 2. Here, that would be 2. And square of this number would be 4. Now let us see the fourth one, 44. And if you subtract 56 from 44, that would be equal to minus 12. And the square would be 144. Now 48. So that would be minus 8. That means 48 minus 56. That would be minus 8. And the square would be 64. Thereafter 45 and that would be equal to minus 11, 121, 60. This is another observation. So 60 minus 56, 4, and that is 16. Thereafter 62. So 62 minus 56, that would be 6. Here 36. And 60 minus 56, that would be 4. 16, 50, that would be minus 6, and that would be 36. So if you sum this one, so that would be equal to 662. So variance would be 662 upon 10. That means variance of x is equal to 66.2, and standard deviation or sigma, that is under root 66.2, and that would be equal to 8.13. You can use calculator. So this was about variance and standard deviation. So this is a very important topic for data science, machine learning, artificial intelligence, and statistics itself. Hope you have understood all the concepts and theory I have presented. Formula you should know. In upcoming videos, I will explain more about statistics, data science, and machine learning, and others videos related to linear algebra which will be applied in machine learning I am also making. So hope you have understood all the concepts. Thanks for watching the video.